Okay, so the second thing that affects the solubility of a generally insoluble salt is known as the common ion effect. So if we take something that's generally insoluble, like barium sulfate, and we add something to it that is much more soluble, so barium chloride is considered generally soluble. It'd be in our soluble list. Generally soluble. And add it to a solution of something that is generally insoluble. Let's think about what should happen. Okay, so in this case, the common ion that we are talking about would be the barium ion. So we're talking about barium plus 2, which is the same ion that I have in barium chloride and in barium sulfate. So if we just think about what's going to happen from the Chatelier standpoint, if I add barium chloride, this is completely ionizing, so I'm going to end up with a high concentration of barium. And if I do that, I'm going to increase the concentration of barium. And pretty simply, what the Chatelier says is that this is going to shift to the left, right, which will give me more solid, so more of the barium sulfate will precipitate out. So adding a common ion always reduces the solubility of a generally insoluble salt. And it's a simple application of Le Chatelier. Let's do an actual problem where we look at quantitatively what's happening with a common ion. Okay, so we want to calculate the solubility of solid calcium fluoride in a 0.025 molar sodium fluoride solution. So this is a +1 alkali metal, so this is going to be completely soluble. So wouldn't you agree that if I have 0.025 moles of this and I put it in water, I'm going to end up with the same concentration of the fluoride ion? Alright, so let's first set up. Alright, so I have CaF2, and that's going to break up, and that's a solid, and it's going to break apart to Ca plus 2 plus 2F minus. And my KSP is given to me, so I'm going to end up with a plus X here, a plus 2X here. So my KSP is going to be my X times my 2X, which is squared. Now, if I am adding a soluble salt that's going to completely ionize, my calcium is going to be concentration of X, but my fluoride concentration is going to be exactly the same as the concentration that I added of the sodium fluoride. So that's going to be 0.025 squared. And all of that is going to equal my KSP, which is 4 times 10 to the minus 11. So my X, which is my solubility, which is how much of this solid dissolves, is going to be equal to 4 times 10 to the negative 11th over 0.025, which is squared, and I'm going to get a solubility, molar solubility of 6.4, I'm not sure if 6.4 or 6.25, times 10 to the minus 8. Let me calculate that. 4 divided 0.025. So it's 6.4 times 10 to the minus 8th. It's going to be my molar solubility. Okay, we're going to stop right there.